Welcome to another mathematics class, and today we are looking at the other applications of bearing and distance to real life situations. During our last lesson, we were able to solve some questions talking about real life applications of bearing and distance, but here we are looking at other cases that we may have. The last one we were solving, they gave us the distance and we are given the bearing as well, and we use them for calculations. But today we are looking at the case where we are only given speed and time, and we be the one to calculate the distance ourselves before using the values that we obtain for the distance to carry out further calculations. And also, after the class, I will also tell you about other areas of life where bearing and distance is applicable. Now from here, some real life applications may involve conversion of speed to distance with given time. And we quickly need to do a recap of this formula, which says speed is equal to distance over time. By the time we cross multiply here, we have distance to be speed multiplied by time. And that is why we have this. That will lead us to example 1. The first example says two ships leaves a port at the same time. There is a particular port, so we have two ships that are embarking on a particular journey, but they are going on different direction. They are leaving the port at the same time. One travels at 5 km per hour. Kilometer per hour is the unit for speed. On a bearing of 046 degree, the other travels at 9 km per hour on a bearing of 127 degree. How far apart are the ships after 2 hours? If you look at the information we have in this question, we are given the distance of the first ship to be 5 km per hour. The speed of the second ship is 9 km per hour, and this is the time. The journey took them 2 hours. And they're asking us now for the distance between the two ships after traveling for 2 hours. So what we do here is we represent the first value that we have there, 5 km per hour. We say let S1 be the speed of the first ship. We use S2 to represent the speed of the second ship. Now for the distance as well, since we are considering 2 hours, so we don't need to represent 2 hours with T1 and T2. So 2 hours for the first one, 2 hours also for the second ship. So we write something else here that let D1 be the distance of first ship. And write also that let D2 be the distance of second ship. Now from here, we replace this speed with S1 for the first ship. So we have S1 to be D1 over T. And we are given the first speed as 5 km per hour. So where we have S1, we replace that one with 5. We are looking for the distance of the first ship, and the time we are using is 2. So by cross multiplying from here, we have D1 to be 2 multiplied by 5. So the distance covered by the first ship is 10 kilometers. Also, we have S2 is equal to D2 divided by T. This second speed, the speed of the second ship, we are given as 9. Then we are looking for the distance. The time still remains 2 hours. By cross multiplying from here to, we have D2 to be 2 multiplied by 9. Then the distance of the second ship is 18 kilometers. Now we have the distance covered by the first ship, we have the distance covered by the second ship, and they've given us their bearings. The bearing of the first one is 046 degree, while the bearing of the second one has been given as 127 degree. So the next thing we do is to sketch our diagram. After after sketching the diagram that we know if we are to apply sine rule or we are to apply cosine rule. So we've obtained D1 as 10 kilometers and we've obtained D2 as 18 kilometers. So before sketching the diagram, we need to look at the two values and we need to quickly do a recap on what we have learned. That the line we use to represent D1 will be different from the line we use to represent D2. If you look at the two, 18 is more than 10. So the line that we use to represent 18 will be longer than the one we use to represent 10. So we take the diagram from here. This is the ports. The first one moved on a bearing of 046, and 046 is a surveyor's bearing. So that will be taken from the north pole clockwise. So this is the north. We have 046 and the distance is 10. So I'll call this one A. And this one, we have obtained it as 10 kilometers. That is our D1. The bearing here is 046 degree. Now the second one, on a bearing of 127. So that 127 is also a surveyor's bearing. Any three-figure bearing is a surveyor bearing. So we also take that one from the north pole clockwise. So we have 90, then 127. But the line I will use for this 18 will be longer than what I have here. So we have this. This one is 127 degree and this is 18 kilometers. I'll call this one shape B. We can use any alphabet to denote the two shapes, but I'm using A for the first shape and I'm using B to represent the second shape. So from here, this is the east, this one is the south, and this point is the center. So I will label that one, we call it the origin. So from here, we need to get this angle and we need to get this angle. From here, I have angle EOA. That is this angle A. Angle EOA, we know that from this north pole to this east pole, what we have there is right angle, which is 90 degree. But we've taken a part of this 90 degree, which is 46 degrees. So the remaining part of that 90 degree will be 90 degree minus 46 degree, which is 44 degree. This place is 44 degree. Now we still have another angle here from this east. This is the south and this is the east. But the bearing of the second shape we are given as 127 degree. We know by the time we move from here, from this north pole to this south pole, we have covered what we call angle on a straight line. An angle on a straight line is 180 degree. And we have this as from here to here is 90. So we still have another angle here. And the angle here will be obtained by deducting the angle represented, the bearing of the second shape, which is 127. So we have EOB is 127 degree minus this one minus 90 degree, and that is 37 degree. So this one is 37 degree, and we have angle P from there is equal to 44 degree plus 37 degree, which is 81 degree. So the whole angle here is 81 degree. Now from here, the next thing now is to check for the rule that will be applicable to get the distance between the two shapes, because the question is asking us for how far the two shapes are after 2 hours. We have used the 2 hours to get the distance of the two shapes from the port. Now we need to get this. This is P. The side facing this angle B, we represent that one with small b. The side facing this angle A, we represent that one with small a. And from here we are given these two, the values of these two lines, and we are given the angle between them. So we quickly need to look at sine and cosine rule. When can we use sine rule? When can we use cosine rule? We use sine rule when we have two angles and any side. And also when we have two sides and the angle facing one of them. But if you look at this one, we have two sides and the angle between them. And from cosine rule, we make use of cosine rule when we have two sides and the angle between them, and when we have all the three sides with no angle. So the suitable rule to get the distance between the two shapes is cosine rule, because we are given two sides and the angle between them, which is a condition that is needed before using cosine rule. So since we are using cosine rule, we state the rule using cosine rule. The side we are looking for, that is P, we state the rule based on the alphabet that we have in the diagram. So the one we are looking for, P square is equal to A square plus B square minus 2AB then cos P. So we substitute the value of A and the value of B. We have P square to be, A from there is 18, then B is 10, minus 2 into 18 multiplied by 10, then cos 81 degree. Now the next thing is to use our calculator for the square of 18. 18 square is 18 multiplied by 18. So we have P square to be 324 plus 100 minus 2 into 180, then cos 81 degree. So P square from there will be 424. When we are using cosine rule, these two, A square and B square, they are together. We get the value of A square and we add it to B square. We keep the result. Now this one, 2AB cos P, we also treat these ones, we treat them together. So after getting a value for this, we now remove from what we have there. That is if P is from first quadrant, because cosine from the first quadrant is positive. So plus multiply, the multiplication of positive and negative is negative. So this one will still remain negative. But if this value, if the value of theta A is more than 90, then that will be from second quadrant. And we know that minus multiplied by minus will be plus. That is when this sign will change. When our angle is from second quadrant or when it is more than 90 degrees. So we have 424 minus 360. If you check our calculator for cos 81, we have 0.1564. If you check we can also check our four-figure table. If you go to cosine of angles, we check 81 under 0. So this is what we have. So we multiply this with 360. We have P square to be 424 minus 56.316. And if we remove this from this, we have P square to be 367.684. So at this point, we have an expression that involves square. And for any expression that involves square, what we do is we take square root. But for any expression that involves square root, we take square. So we take square root of both sides. By taking square root of both sides, we have square root of P square is equal to square root of 367.684. Square, we cancel square root, then we have P to be 19.18 kilometers. Therefore, the two ships are 19.18 kilometers apart after 2 hours. And that is the solution. So the two ships, after going on different direction, on different bearing as well, and covering different values of distance, so they are 19.18 kilometers apart. Even me looking at this diagram, before going on with the calculation, if you look at the diagram, we notice that line AB is the longest line there. So when we are solving this and we are having an answer that is less than 18, then we should check what we are doing, because something might have gone wrong in the course of doing the calculation. Maybe as you are pressing calculator, or maybe as you are checking the four-figure table for the value of cos 81. But from the diagram, this is the longest side and the value must be more than what we have must be more than 18 and must be more than 10, and that's why we have it as 19.18 kilometers.